Our first speaker is Brian Dobbs, Brian Cory Dobbs. He's an award-winning director, editor, and screenwriter. His most recent film, Blue Planet Red, explores the theories and history of the enigmatic planet Mars and their implications for the understanding of our own planet. You can check out blueplanetrед.net for more information on the film, or his website, briandobbs.com. But with no further ado, Brian Dobbs.
All right, good morning, everybody. How's it going? Okay, so we're here at a UFO festival, and here's a guy on stage who wants to talk about Mars. What's the deal with Mars? Most people think that it's this boring desert wasteland. I was one of those people until I went down a rabbit hole. You ever do that? Just find out some stuff. There's a lot going on with Mars, I'm going to show you. But first, it won't, oh, Scotty, give it up for Scotty, he's the man here. First, who remembers this song from the 80s? Yes? Okay. And whose song is it? Cyndi Lauper, that's right. But it's not. It's not her song. It's a song actually by Robert Hazard, who wrote and recorded it just a few years prior. Now, if you're like me, you might be thinking, this can't possibly be true. Everything I've ever known has been flipped upside down, turned on its head. What's real, what's not, I don't know anymore. And I think that's the reason most of you are in here today. That at one point in your life you were confronted with this idea, especially here in Wytheville, that there's something more going on than you've been told, than you've been led to believe. And it required you to transform inside. Required you to think about what's really going on, independent of what other people think, independent of what you hear on the news media, and this is not a political stage, but again, you know, what makes the nightly news isn't necessarily everything that goes on in the world, okay? This subject matter of UFOs and aliens and NHIs and all this kind of stuff, it's a lot to take on, okay? So congratulations, thank you very much for being here, because I think it's your enthusiasm and everyone else who follows this subject that's really starting to build momentum here. And believe it or not, well, I'm here to make the case that Mars should be included in this discussion. Okay? So we look up in the sky and we see something funny. And we're mesmerized by it. We don't know what to make of it. Who here has a personal experience or knows someone who's had a personal experience looking up in the sky, looking at something, seeing something strange? Okay, quite a bit of you. That's great. I have not, but I see a lot of stuff online, and it's awfully compelling. So, let's go to Mars, shall we? Tell me, is there anything in this photo that just kind of looks out of place? Now, I know what you may be thinking. Brian, we're here at a UFO conference. I've seen better UFOs than this. That's probably just a problem with the camera or something. Not a big deal. Maybe it's a pixel or something, I don't know. But they took a photo. This is from the Curiosity rover. Apologize, the text getting cut off. Not a big deal. This is from the Curiosity rover. And they took a photo a minute later, or rather a few seconds later, and guess what? It's not there anymore. So we know it's not a camera problem. Was it a piece of dust? I don't know. Not sure. What about this one? Wow, what a boring photo, Brian. Okay, I'm going to give you a little hint here. There's something in the sky. It's really small. You can probably barely see it. It's maybe about a pixel or two big. Okay? You guys see it? Some of you? Right there? Oh, man. Oh, geez, Brian, is that the best you got? Well, what I find so fascinating about this photo is that a few seconds later, 12 seconds, I think, this little dot moved over there. We know it's not a dead pixel on the camera. We know it's not a piece of dust. Now, 12 seconds after this photo was taken, this photo was taken. So, one could argue this is, well, maybe it's just something blowing around in the wind. Maybe it's a bunch of, maybe it's a piece of debris from the Curiosity rover or the lander capsule or something like that. But I need to remind you folks, the Martian atmosphere is nothing compared to Earth, okay? It's less than 1% density. To blow anything around on Mars requires, I don't know, but you remember the opening scene of The Martian, Matt Damon, there's this big sandstorm and it's blowing everything around and the rocket can't take off. Okay, it's a fun movie, not gonna hate on it, but that really wouldn't happen, okay? The most you can blow around on Mars is dust, maybe some sand, not much more. What the heck is this thing? Now, Mars used to be a blue planet. Science now shows that it used to have a thicker atmosphere, it used to have oceans, and scientists think that it used to be a blue planet before Earth. But now we know Mars as the what? That's right. Ooh, it's a scary looking planet. But you know what? Doesn't really look like that. Looks more like this. More of a brown. As my friend Barry likes to say, it's more of a butterscotch. Okay? And Mars, well, let's take a look at a rover photograph, a typical rover photograph. This is what NASA beams back to us, and we see stuff like this, okay? Boring desert wasteland, thousands of these photos. What's the big deal? Well, interestingly enough, NASA has actually been tinting their photos artificially, okay? It doesn't really look like this. We're not exactly sure why. They've owned up to it, and they've started releasing true color photographs. And here's one from the Perseverance rover, the latest rover they've sent there. Right after it landed, what do we see? Huh, that kind of looks like a desert here on Earth. Kind of brownish with a blue sky. I want to go there. Maybe. Mars is actually filled with a lot of different colors. Quite scenic, actually. You take a look at some of these photographs and you're thinking, geez, that's Mars. That's not the Mars I know. That's not the Mars NASA told me was up there. Here's one little dust devil. It's kind of a neat photo. Mars has got some funny looking things up there too. Here's an interesting one. Geez, this is so not red. I can't believe that's Mars. But it is. Bluish. with all that blue, a little bit of white, you might start to wonder, could there be any water on Mars? Who here thinks there's water on Mars? Oh, okay, quite a bit of you. Let's dive in. Here is Korolev Crater. Okay, this is towards the North Pole. This crater is 50 miles wide. If you were to melt all that ice, it'd be over 500 cubic miles of water. That's a lot of water. Okay? But Korolev Crater is nothing compared to the rest of the North Pole. Let's a closer look at it. How much water's up there? A lot. Okay? So, when scientists talk about finding even just microbial life elsewhere in our solar system, what do they always talk about? Let's look for water, because that's most likely where life is. Because here on Earth, where we find water, we find life. Even in the most salty conditions in the deep seas, you still find microbes swimming around down there. So they'd like to talk about the moons of Saturn and Jupiter, of which we should go, ice-covered moons. Fascinating. But I'm here today to make the case that we should refocus our interest on Mars. It's right next door. We've sent stuff there. We can go back again, this time, maybe next time with humans, to go take a closer look at some of this stuff. It still does have an atmosphere, not much, but microbes don't need much. Okay? So, now, if we were to zoom down to the surface, dig around a little bit, centimeters beneath the surface, you can find this white stuff called ice. We know it's ice. NASA, there's a whole page. First of all, let me just clarify here. All these photos, all the stuff I'm talking about, most of this, in fact, if not all of it, okay, this is photos and data collected by NASA. As to why they don't make a bigger deal out of it, I don't know. So that's why I'm making a bigger deal out of it. And I'm not the only one. A lot of this, what I'm showing you today, is based on the work of many scientists, many brilliant people who I'll talk about during this presentation. Sorry, I'm a filmmaker. Okay, so you go to Mars, you kneel down, you dig a little bit with your hands, boom, you find some water. Okay, meteor comes down, smacks right into the planet. What's it going to find? Guess what? It also finds some ice. Several hundred meters beneath the surface, we've also detected large, deep subsurface lakes and ice deposits. I think I read one time where one of these ice deposits was as large as the Red Sea. So we're talking about quite a bit of water. Now, when I say water and ice, it's the same thing, okay? One's colder, but we know microbes can live in ice here on Earth. They don't need much. In fact, some of them melt the ice around them with a natural antifreeze and get nutrients out of it to eat. Okay, so where we find water, ice, whatever, we normally find life. Now you go back up to the surface and you find these funny looking streaks. Now through the process of, an interesting word here, deliquescence, this is when the soil actually absorbs moisture out of the atmosphere and releases liquid water that runs down these hills here. Okay, I believe this is an orbiter photograph, but that's clearly a rover photograph. NASA says we're looking for water on Mars. They found it. It's right there. Okay? So if you have ice a little bit under the surface, just centimeters, okay? If you have water trickling on the soil like this, is it any surprise that the rovers would collect mud on their wheels? Now, when they descend anything, a lander, a rover, whatever, descent, requires controlled entry, and so the thrust of the rocket engine sometimes will heat the soil as it's landing. Okay, so the Phoenix lander captured these photographs of water droplets right on its landing struts. Okay, these are photos by NASA. There's a whole paper published by, guess what, scientists of NASA talking about how these are water droplets. I don't know why they keep saying we're looking for water. It's right there. Now, perhaps the most exciting thing to think about is the prospect of a winter wonderland on Mars. Wouldn't that be nice? In 1976, the Viking lander captured this photograph of snow on Mars. That's really cool. And we know it's snow and not frost, because if it were frost, it would be covering both horizontal and vertical surfaces. This is just covering the horizontal surfaces, so it's snow. This is just a light dusting, though. Okay? The question is, how much snow actually does fall on Mars? Well, a scientist at NASA said regarding snowfall that enough falls that you could snowshoe across it. It's a lot of snow. Those are not trees. Some people think they're trees. They're not trees. It's just the underlying soil coming through. Okay? Where does snow come from? What's in the sky? That's right. H2O in the clouds. There is water on Mars. If there's water, what else could there possibly be? That's right. Now, as we understand microbes here on Earth, where are microbes? Where do they live? That's right, they do. They're everywhere. They've even found microbes inside nuclear fuel waste. They're hardy sons of guns. They've even found microbes on the windows, on the outside windows of the International Space Station. More than once. It just keeps on accumulating there. They've even found microbes on the exterior portions of some of the moon landers years after they were up there. So these little critters can survive quite a bit. Are there any microbes on Mars? Well, in the 1970s, NASA, oh man, they were real serious about this. Like, we're going to go to Mars. We're going to figure out what the hell's going on there, okay? Is there any microbes on Mars? Well, NASA really beefed up their budget. They got a whole big team together for the Viking mission. Some of you may remember that. And here we have a picture of the Viking lander next to the late Dr. Carl Sagan. Okay? And they sent two of these things in 1976 to Mars. This is before those cute little rovers that they send who take selfies of themselves and tweet these days. This is incredible. Okay? And aboard each one of these Viking landers was a life detection test. They wanted to get to the bottom of this quickly. This life detection test was technically named the Labeled Release Experiment. Okay, it's just a schematic, all right? But if you simplify this, here's how it works, okay? Here, get out of the way so you don't see this. First, you take some dirt. You give it to something to eat, and you see what comes out. That's it. Okay? Now, it may not sound that sophisticated, but trust me, it is. This labeled release experiment was invented and designed by the late Dr. Gil Levin. Okay? He's an engineer, sanitation engineer, okay? He understands microbes and water inside out better than anyone on the planet, and he invented this thing. And this thing was run over 4,000 times here on Earth. It even tested samples from the moon dust, and it even tested samples from Antarctica. And believe it or not, even a half century ago, we weren't really sure if there was any microbes down in Antarctica, okay? But this thing found it, and what I find so incredibly interesting is that this thing never failed. It never produced a false positive nor a false negative. It was a perfect test. So he submitted a proposal to NASA. He said, hey, I got just the thing you're looking for. And it's got a great track record. And they took a look at his data, and they're like, you're right. This thing's awesome. Come on, Gil. We're going to put your labeled release experiment on the Viking mission. And joining him was a lady by the name of Dr. Patricia Ann Stratt. And here you can see, this is a nice photo, okay? I think that's it right there. And she helped him adapt this experiment to fit the constraints of the Viking mission, okay? So, they sent this thing to Mars. It scooped up some soil, fed it some chicken soup, as they nicknamed it. And within a few weeks, they got their first result. Now, who here thinks that the labeled release experiment aboard Viking went to Mars and tested positive for life? Okay. Now remember, they sent two of these things. One Viking lander over here, thousands of miles away. On the opposite side of the planet, they sent another. This is incredible, folks. The Viking mission, they sent two of these things. Two orbiters and two landers. The orbiters took satellite photos and measured atmospheric stuff. The landers went down and took additional measurements, but they sent two of these things. They worked flawlessly. This is amazing. Back in the mid-1970s, this is incredible. Incredible engineering by NASA. Don't get me wrong. NASA has done incredible things. I'm not here to bash NASA. I'm here to question why they aren't speaking more openly about some of their own data. Okay? So they sent two of these things. Who here thinks the other one tested positive? Hell yeah, it did. Okay? Now, at this point, they could have celebrated. They could have broke out the champagne, as Dr. Gil Levin has said, or maybe some beer, whatever your pick is, and said, yes, we found life. Here's the Nobel Prize, Dr. Levin, way to go, buddy. That's exactly what you were here for. But NASA hesitated. They weren't so comfortable declaring that they had found life on Mars. Why? Because there was this other experiment aboard Viking, and it's got a long name. I'll say it once. It's called the gas chromatograph mass spectrometer, okay? And its sole purpose was to test the soil for organic matter. And its test came back negative. So NASA was saying, well, there's no organic molecules in the soil, so how can you have life without organic molecules in the soil? So they said the life test results were ambiguous. And since then, they've just said, well, there's no evidence for life on Mars. Okay? The problem is the gas chromatograph mass spectrometer wasn't a well-designed test. It wasn't sensitive enough to test the soil. Okay? We know this because Curiosity, everyone knows the Curiosity rover, they sent that decades later, and guess what? It found organics in the soil. They were there, and had they tested that positive in 1976, they might have said, well, Gil, maybe you're onto something here. We support you. But no, instead they pushed him to the side, they marginalized him for decades. Unfortunately, he passed away a couple of years ago without ever having his research vindicated, okay? So I'm here today to try to tell you a little bit more about that, because we can't forget, okay? So this idea that there's no organic molecules in the soil is wrong. Okay, not only did Curiosity find organic matter in the soil, it also found something funky called dimethyl sulfide. Now, I never heard about this. You guys ever hear about this? It's just an organic substance. I don't know what it does, okay? I don't know what it looks like, but here's what you got to know. Here on Earth, the only way you can get dimethyl sulfide is through microbial activity. Microbes are the only thing that produce this. Has anyone followed up on this? They're just going to shrug and move on? Moving on. NASA scientist Dr. Carol Stoker found evidence through the use of spectroscopy. It's where you shine a light at something and see what wavelengths reflect back. You can tell what kind of material it is. Well, guess what? She found chlorophyll. Did we follow up on that? Apologize for the text over there. Okay, so here's something interesting. Anybody ever hear about rock varnish? This is also known as desert varnish. All right? All right. What is rock varnish? Well, if we were to ask Barry DiGregorio, who's an author, an astrobiologist, an honorary research fellow for the Buckingham Center for Astrobiology in the United Kingdom, who literally wrote the book on a lot of what I'm talking about here today, he describes rock varnish as thus: rock varnish is a very hard, dark, but shiny coating on rocks and pebbles, which is produced by chemical and biological weathering processes after many thousands of years. Almost all rock varnish is produced as a result of bacteria, fungi, algae, or lichens pulling chemicals from the rock and creating new layers over centuries of time. And we see it on Mars. This isn't sexy stuff, folks. I know. Don't worry. I got juicy stuff coming. Okay? But we got to get through the microbe stuff first. We talk about microbes because most people are so frightened by this idea that there are other beings. Okay? Mars has a less conflicting entry point for the gen pop out there who just simply isn't aware of this stuff, okay? No one's going to be afraid of black slime on a rock, all right? Have we followed up on this? Now look, these are NASA photographs, and folks at Los Alamos have studied this stuff. And because they are under the pretense that there is no life on Mars, they're trying to come up with a chemical explanation for this. They're bending over backwards, twisting in all sorts of ways to try to find a way to get rock varnish on Mars without life. So they're looking at it. So, moving on, what about fossils? Oh man, getting deeper here, folks. Okay, fossils, let's start with the small. Some of you may remember that in the 80s, there was this meteorite that landed in Antarctica, okay, and they studied it for years, and in 1996, Bill Clinton had a big press conference about it, all right? It's called the Allen Hills microfossil, all right? And it came in a meteorite that scientists have confirmed that did come from Mars. It's a tiny little worm here. This is a famous photograph. I see it in my daily news feed every few months or so, okay? And you look at it and you're like, maybe, maybe not. Scientists still debate this to this day. Now, this is the most well-known example of a microfossil in a meteorite, but in my opinion, it's not the best example, okay? I was surprised to learn, making the documentary about Mars, that there are other microfossils that just never made the news. Here's one from the Polonnaruwa meteorite. And what we see here is a diatom. Has anyone ever heard of a diatom? Okay? A diatom is a microscopic plant that produces much of the oxygen we breathe here on Earth. Okay? They're all in the oceans, all right? They actually take them out of the oceans and dehydrate them and grind them up, and we use them in our pool filters, diatomaceous earth, and gardening, and beer brewing, okay, for their excellent filtration qualities. They're quite porous. Diatoms have a unique shape, and Professor Chandra Wickramasinghe, okay, the pioneer of panspermia. Anyone ever hear of panspermia? Okay, you have this man to thank. He popularized the term. He didn't invent it, but he's done decades of research on panspermia, and this is something that he discovered in the Polonnaruwa meteorite, okay? All right, so here's that. Does that look like part of the rock, or does that look like a little critter? Okay? And if you're not convinced by that, maybe you might be convinced by these. More diatoms, okay? I don't know how anybody looks at this here on the left, any one of these, and says, yeah, that's just part of the rock. I think to the untrained eye, these are more obviously not just geology. All right, now these were discovered by NASA scientist Professor Richard Hoover. Professor Richard Hoover was NASA's lead astrobiologist for decades at the Marshall Space Flight Center. He's got 11 patents and was NASA's Inventor of the Year in 1992. Folks, if NASA's lead astrobiology guy says, we found microfossils in a meteorite, why are we not believing him? Why is NASA not making a bigger deal about this? He has conclusively determined that these are not the product of terrestrial contamination. Okay, rocks didn't fall from, oh, by the way, these came from the Orgueil meteorite, okay, which fell in France in 1864. He cracked it open, found these bad boys, and said, boom. Due to their lack of nitrogen content, we know these things. If an organism dies, it still has nitrogen in it, okay? If there's no more nitrogen in it, we know it's been dead for a very long time. These critters did not jump in the rock right before he put it under a microscope. Okay, these things have been in there for millions of years. The Orgueil meteorite, some believe it is from Mars, okay? All right, let's move on. Now, what about larger fossils? Let's talk about something called trace fossils. Anyone ever heard about trace fossils? Okay, you probably have, and maybe one person here, okay? Trace fossils, think of it like a footprint, okay? It's not the dinosaur skeleton, but it's its footprint, all right? We love footprints, they're great, okay? It tells us something was there. Now, dinosaur footprints are pretty awesome. Let me ask you this. What do you think a worm footprint would look like? Yeah, squiggly, not too much with it. All right, here are two photos, okay? One is from Earth and one is from Mars. Okay, who here thinks that the one on the left is from Earth? And who here thinks the one on the right is from Earth? Okay. Okay, my friend Barry DiGregorio found these ones over here, sifting through Curiosity rover images. Okay, you got to hand it to these guys who just sift through thousands of photos every day just looking for weird stuff. NASA is legally obligated to publish these things, but they don't have to make a big deal about it. Okay, they leave it to you and me and Barry to go looking through these photos and say, hey, look, I found something interesting. They post it online. And whether or not it gets any attention, I don't know, okay? Barry wrote a whole book about these trace fossils. All right, here's something else interesting. What you see on the right here is something called a crinoid. Anyone ever hear of a crinoid? Yeah, not many, right? Crinoid's like a flowery starfish. Okay, it's an animal. It looks like a plant, but it's an animal, and it's got a stalk that attaches to the seafloor. Okay, now on the left we see what a fossil of a crinoid looks like. Okay, and you can see the stem comes up here and it bifurcates and then splits off. All right, so 2 more photos for you. Which one is from Earth? Which one is from Mars? Okay, who here thinks that the one on the left is from Earth? Yeah, okay, and then the one on the right? Okay, we're somewhat sure about this. I know it's really weird. You don't have really good photographs here. Well, guess what? The one on the left is from Mars, the one on the right is from Earth. Okay, we see a stem and a bifurcation. It's not much, folks. But the Opportunity rover in 2004 took this image. Now, this thing's only a few inches big. It's not that big. Okay? Did we follow up on this? Did we sit there and analyze it for a month and make news about this and get... See, the problem is NASA is so interested in geology that they've forgotten the other areas of study. Okay? Paleontology. Okay? And as we're going to get to in a minute, archaeology. Biology. All right? They just simply forgotten about these and they prefer geology. Why? I don't know. But does geology really scare people? Not really, unless we're talking about earthquakes and volcanoes, I guess. So anyway, let's move on to funny-looking rocks, okay? All right, so the rovers have taken some really interesting photos. All right, now tell me, what does that look like? Does it look like a rock? Maybe? I don't know. Should we take a closer look at that one? Yeah? Okay. What about these two? Do those look like rocks we have here on Earth? Awfully strange shapes here. In fact, NASA thought this one looked really peculiar as well. They took this photo and they sent their rover about its merry way. And as they were looking through images it took back here on Earth, they're like, ooh, this is really weird. Let's go back. So 12 days later, they went back and took more photographs with different instruments and different wavelengths. And shout out to my buddy Jeff in Australia for putting this together. He analyzed this. Thank you, Jeff. So clearly they were interested in this one particular rock. As they should be. It looks kind of weird, all right? What about this one? Now, apologies for the poor resolution here, folks. A lot of these photos, as you know, are taken with wide panoramic camera angles, okay, that shows you a vast wasteland of just rocks, all right? And to find something like this, you got to zoom way in, so the resolution isn't that great. So, but if you pan out here, all you see is just little tiny rocks, and this is just kind of a little anomaly there. I don't know about you, but it looks like you can grab the top of that thing and lift it and stick it somewhere. Don't know what it is. What about this one? Again, there's nothing else like this in the surrounding landscape. Okay? Arguably, one could say it has symmetry to it, a circular shape, something protruding from the center. Looks kind of weird. Maybe we should take a closer look. That's all I'm saying, folks. I'm not claiming this is something in particular, okay? I'm not certain of what this is. I'm just simply saying we should take a closer look. Why didn't the NASA rover drive up to this thing, get right up on it, take a few photographs all around it? I don't know. It just said, okay, nothing to see here, move on. What does that look like? Thanks to my buddy Rami Bar Alan for some of these photographs here. He also looks through rover images and finds some stuff and does his best to try to bring out the detail a little bit better because NASA isn't doing it. Rami is over in Israel. I hope he's doing okay. What about that? Okay. Now, here's what we typically see. Just a big old panoramic shot, bunch of boring rocks. There's one funky thing in this image. Something that doesn't look like the rest. That thing. Yeah. Okay. Huh. We have a rugged landscape, but we look down here to this thing. Let's take a closer look, thanks to Rami. What could that be? Smooth, circular. Some people, he does describe it as a cone. To me, just to me, to my eye, it looks like a column that is buried in something. I'm not saying that's what it is. I'm just saying that's what it looks like to me. Okay? What rock is so perfectly smooth like that? I don't know. What does this mean, folks, if these aren't just rocks? That's the question I have. If these aren't just rocks, if they were... What about that one? What the heck is going on with that rock? Such a weird looking thing. You know, I'm not used to seeing rocks like this here on Earth. I don't know about you guys, but what I put in here is stuff that I just haven't seen. Now look, I haven't seen everything, but I've seen a lot. We have the internet now. I mean, my goodness. Again, this is blurry as heck. I'm sorry. Part of a larger picture, but you zoom in on it, you can at least get a shape. Okay? Shouldn't we take a closer look at that one? All right. What about funny looking hills? Okay? Funny looking hills. Okay. Now, about a few years after the Viking mission got there, started taking photographs of the landscape, we also found this. Okay, you guys remember this, the face on Mars. Oh, here we go, the face on Mars. Oh, goodness, here we go. We can't make a documentary about Mars without talking about the face on Mars, okay? Now, this is an updated photograph of it. The original one was much lower resolution. We're going to show the updated one. Okay, now, this face on Mars was not discovered by, but analyzed by Dr. Mark Carlotto, who's an aerospace engineer. He specializes in image processing, pattern recognition, mapping, and machine learning. Okay, if there's anyone qualified to look at satellite imagery and figure out what the heck is going down on the surface, it's this guy. He works in the aerospace industry. He's been doing this for decades. He knows what's going on. So Dr. Mark Carlotto took a look at this face. Again, this is back in the 80s, and he's like, here's what I see. I see 4 dots running right down the middle of the face. Okay, not a big deal. See these little 4 dots? Actually, it's circles, ellipses, not exactly perfect. But if I scroll back and forth here, these 4 dots right down the middle, more or less. Okay? Okay, big deal, Brian. Well, guess what? He started drawing lines through them. Oh, now so that's something interesting. You start drawing lines through this stuff, you get repeated expressions of 3, 4, 5 right triangles. Now, let's just take the face away for a second. Forget about the face for a second. All right? What we see, if you look at the frame of this thing, the frame is symmetrical, and it is defined by the inner 3, 4, 5 right triangles and the outer 3, 4, 5 right triangles on all sides. Okay? That's kind of neat. Does nature do that? I don't know. Then he started drawing some ellipses through these. And the ellipses identify this. I mean, look at this curve, folks. I mean, this thing's over a mile big. Does nature do stuff like that, make it sort of perfectly curved there at the top and there at the bottom? I don't know. We should probably go take a closer look. Is that a face, and why? Well, why the heck would they even make something like that? Is it a face? I don't know. It's not pristine. I will grant you it's not pristine. I'm not claiming it's intended to be a face. But some could say, hey, it looks like a face. You draw a smiley face on a piece of paper, someone's going to say, hey, that looks like a face. Okay? Whether or not it's intended to actually be one, I don't know. All right? But why isn't it not pristine? Well, what would the Sphinx look like in another 5,000 years? What about another 3 million years? What would the Sphinx look like? Okay? And why is the face on Mars just pointing right up? That's a good question. Why do the Nazca lines in Peru, why can you only see these things if you're up in an airplane? And these things, these are geoglyphs carved into the surface of the earth They're huge. If you're standing on the ground, you can't see them. But if you go up in the air, guess what? You can see all these things. Did they have airplanes thousands of years ago? They still carved them to get somebody's attention, maybe. Who knows? Anyway, here's my friend Gary. Now, my friend Gary, he's an image expert, and he takes the face and he uses the shadows of the face to draw out some a little bit more detail and offers us and is able to offer us a 3D rendering of it. So here's just a bird's eye view of the thing. You know, say of it what you will, just an interesting different view. It would be interesting if NASA did this, but they don't. So my buddy Gary takes it upon himself to do this. Gary's one of these folks who goes, he's so funny, he says, every night I go to Mars, and he does. He sits on his computer every single night, and he, believe it or not, the Google Earth Pro program actually has a toggle for Mars. So you can scroll through Mars, and that's what he does every single night, just looking for weird stuff, okay? Okay, I'm going to try to wrap this up real quick. Anyway, another profile view of the face. All right, now here is the D&M pyramid. If you go on NASA's website right now, they will actually call this the D&M pyramid. D&M stands for DiPietro and Molinar. Okay, this thing's 3.5 miles long. Okay, and if you were to look at it from right above, centered, you'd notice that it has these repeated expressions of geometry. Okay, 3.5 miles long. Does nature do that? Is that a volcano? I don't know. What also, and again, such a funky looking shape, you know, I don't know why anybody would design something that looks like that. But if you go back to, this is a place called Cydonia. This is where the face and the D&M pyramid are. Okay, they're right next to each other. What are the odds of that happening? They're both oriented in the same way, and they determine the dates. When they can't carbon date a pyramid, they sort of are able to determine when it was built based on its alignment to true north. Okay, and these things are aligned in the same direction. What are the odds? Here's something else called crater pyramid. Now, if you have a hill next to an impact crater, meteor comes down, what happens to that hill? And everything else around it. Right? So, if this isn't a volcano that just suddenly sprung up right next to this meteor impact crater, you can kind of see it's got some, well, it's hard to see the details. Again, this is 2.5 miles wide, 1.7 miles wide on the pyramid. You bring out the detail, my buddy Gary brings out the detail, okay? And if nature doesn't do something like this, then you have to consider the alternative, that it was created afterwards. There's nothing else like it in the surrounding landscape. Now you might say, well, Brian, it doesn't really look like a pyramid, okay? But again, think about what an unexcavated pyramid looks like after thousands of years. You scroll up to one, all right, here's Chichen Itza in Mexico. You can see 100 years ago, it just looked like a big hill with a little building on top. You excavate it, and boom, there's the pyramid. Teotihuacan in Mexico looks like a big hill, not so precise with its angles. You remove the dirt, and boom, there's a pyramid. Is it too hard to believe that this image here on the left, taken from an orbiter, could simply be an unexcavated pyramid? If you look at Teotihuacan in Mexico, it's squarish, it's flat on the top, it's got this thing in the front. Credit goes to my buddy George Haas for noticing this. Okay? Question is, what turns a blue planet red? Blue planets have thick atmospheres. Okay? Means a breathable atmosphere, and an atmosphere thick enough so you can form liquid water. All right? NASA will tell you that the solar wind has stripped away the atmosphere. Okay? Which is true. It does strip away the atmosphere, but it hasn't stripped it away enough. It doesn't strip it away fast enough to reduce it from what we have on here on Earth to 1% of what we have here on Earth. Something else did it. And that something else caused Mars to lose its atmosphere fast, cosmically speaking, overnight. Okay? Dr. John Brandenburg, who is a plasma physicist, has connected a few dots. Anyone ever hear of Dr. John Brandenburg? Okay. Dr. John Brandenburg has put together his hypothesis based on data collected by who? NASA, okay? And the NASA data reveals some interesting things we'll get to in just a second. And he calls this the Large Planetary Climate-Altering R-Process Event. Geez, what the heck does that mean? Sounds confusing, sounds boring. And he's released this, he's published this, and he's been working on this for decades. And so far in the scientific community, it's been received with crickets. No one wants to talk about this, no one wants to refute him, no one wants to debate him. You tell me why afterwards. And here's what he's put together based on evidence, based on data collected by NASA, okay? There are 3 radioactive hotspots on the surface of Mars. In these hotspots, there is natural glass, all right? The kind of glass that forms when you superheat soil. In the atmosphere of Mars, you have elevated levels of xenon-129. Xenon-129. Xenon's a gas. 129 means it's an isotope of xenon. Okay? Isotope just means it has a different number of neutrons in the nucleus versus the regular version of the atom. Okay? So, what makes xenon-129? Our process. Our process creates xenon-129. What the heck is our process? Our process is the physics that happens inside. It happens in 2 different ways. It happens when a star explodes, a supernova. It creates a lot of xenon-129. Okay? So, well, did a star explode and put a lot of xenon-129 on Mars? No. Because if it had, it would have also placed a lot of xenon-129 everywhere else in the solar system. Mars is an anomaly in this respect. Besides the fact, if there was a star close enough to our solar system that blew up, it would have blown everything else up. There would be nothing left. So we know it wasn't a supernova that put the xenon-129 on Mars. So what was it? What else creates our process? Does anybody know? Anybody want to guess? That's right. The only way you can produce elevated levels of xenon-129 is by supernova or by thermonuclear explosion. Now, there are no craters on Mars in these radioactive hotspots, but there's no craters in Japan either. You have radioactive hotspots without craters. You still see the buildings here. How much energy was released in Japan with the first atomic bomb explosion? In Hiroshima, you have 6 times 10 to the power of 13 joules of energy. That's a lot. Okay? What about the meteor impact that is most commonly credited towards destroying the dinosaurs? Okay? You have 10 to the power of 23 joules of energy. It's a lot of energy. All right? The amount of energy that Dr. Brandenburg has calculated that ignited the atmosphere of Mars, which is what they were, anyone see Oppenheimer last year? Remember the near zero part? There's a near zero chance we're going to ignite the atmosphere and destroy all life on Earth. Okay, we'll go ahead and run the test. Fortunately, they ran the test, and it didn't destroy all life on Earth. Okay? How much energy did it take to ignite the atmosphere of Mars? 10 to the 25. 10 to the power of 25. This is what Oppenheimer and his team were afraid of. This exactly. Igniting the atmosphere, which requires a lot of heat, a lot of energy. And a way to supercharge an atomic bomb is by wrapping the explosive material, uranium, plutonium, I forget which, in thorium. And those radioactive hotspots have thorium, irradiating thorium. Okay? Mars was destroyed. Yes, by meteors. Yes, by natural catastrophes. But that's not the whole story. It's not necessarily a question about what destroyed Mars, but by whom. assuming that inhabitants, if they were there, didn't do that to themselves like we fear we're going to do to ourselves. Mars was a blue planet that turned red. Almost done. Thanks to these folks. Give them a round of applause. These are the scientists whose work this presentation is based off of. Real quick about the film. Avi Loeb is in it. Robert Schock is in it. What made that giant scar on Mars? We get that into the film. I made a documentary about all this. We talk about this in the film. And also, what was the U.S. Army's interest in Mars? Okay? The film has been in 3 different film festivals. It's available. It's got 4 awards. I have some Blu-ray and DVD copies, as well as Vimeo discount codes if anybody would like to see the film. And yeah, can we do the quick trailer? I'll just show you a 60-second trailer. What do you know about Mars?
I know it's a planet that ain't got shit out there.
We don't know what's over there.
Thank you guys very much. Appreciate it.
Yeah, thanks again, Brian Dobbs. For sure.